Hello friends, this is Siri from Siri Tutor Blogs. Today we are going to see about some more examples on lambda expressions. So last time we have seen about the functions, normal lambda functions and functional interfaces. So to just to give you a recap on what we have done is a normal function that is implemented inside a class. Like say for example, um, a normal method which returns a integer type, and it takes two parameters a and b. What it does is it's just gonna return a plus b. So this is a method which takes two parameters. There is another method which accepts only single parameter as a input, and then the main intent of this method is just give a half of this value. It returns a half of the value. Um, Double, it returns a double, right? That's why it is complaining. And another method we have looked into is um, which returns a string method. Okay, and okay, this is a short message that we have. So so um, so um, So instead of writing the whole method, we don't need to write the whole method. Instead, we can declare a function. What lambda's expressions are saying is you can just simply declare a method like this, which takes an integer as an input, and then it takes an input, integer as an input, and what this is the lambda expression that we have to put in. And what is it supposed to do? It's this is the operation that it happens on that input. This is the typical lambda function. So um, so it's taking a single integer, right? And yeah, it should be divided by instead of a modular sign. And what is wrong with this? Why is it complaining? Should be function, right? Yeah, it is complaining because every function, as I said, will take an input value as an integer, and see if you hover on the function, it's gonna take two parameters. One is input value, and another one is and even the function yes, here now we got it appropriate. So when you hover on it, it will show you what exactly it is taking. It is taking two parameters, which is one is the input parameter and another is a result. So we did not give the result, so we have to give as double is the result that we have to give. And then system dot out dot println this out. Yeah. So the way we call the function is f dot apply and and the input values. So this is how we have to give, and we can get rid of this method. We don't need a method like that. So, and the same thing with the variables of two parameters, like the method with the two parameters. For that we have to come up with bifunctional lambda expression, which will take input as integer. We are giving two inputs as integer, so we have to declare two integer variables, and the return type is also an integer. So we are going to give the same data type for all the three, and then we are going to declare it as add. And what is the input values we are giving? Here we are giving just one input variable, but here we have to give two input variables. Okay, and what are these two input variables are trying to do? The operational. Now we have to give the operation of those two input values. We are going to do a plus b, and then yeah, a plus b, and then the result is going to come into this third variable. And let's print this out. The way we have to call this function is add dot apply, and then let's give the input variables 20. Yeah, this is how we have to give, right? And the last one, and then we can get rid of this function as well. So for our references, I'm just keeping it as it is. Once we run it, we don't need that the above methods here. Then another one is like function. What it is accepting, it is taking, you can give an input string and you can give an output string, output as a string data type, and then MSG, and S, you're giving an input as some input variable, and then the output is going to be it's going to be the same. So basically you're not calling this method anymore. You're not calling this method anymore. You're returning this this message, and the way you have to print it is msg dot apply, msg dot apply, and you can give any input values, but you will see that output. So let's run this. So this is how you're going to get it. Yeah, this is how you typically you typically convert a normal function into a lambda function. Let's look into the interfaces now very quickly, and then let's jump into the other part of the lambda functionality. So you can create you can call. So functional interfaces are the methods, are the interfaces which have only abstract method, one and only abstract method. So the way we declared last time is we created an interface. We created an interface, okay, and we have declared interface method here, abstract method. Okay, and this is how we have created the abstract method. And now we will come back to our class. We are going to implement that abstract method in our class demo implements interface. Okay, yeah, this is the interface. Now let's override the method which is declared there. We don't need all these things. Okay, what we simply do is a plus b. This is the basic implementation, just to make you understand how the functional interface works. So this is how we have implemented in our class. So to call this method, we typically, like, the normal way of doing is we create an object of this demo class, right? We create an object of this demo class, and then we pass on the values, right? And because it is returning the value directly, we can just print it out in sysout statement, right? um, sysout statement. So when you print this, you will get 30. So what uh, uh, lambda functions is saying is, you don't have to implement this function like this, right? And one more thing before jumping into the lambda functions, this can be called using the interface reference as well, right? This is also the another way of calling the same method with the parent class reference. Okay, so before so there are two ways of calling the classes. um, so we don't need to uh, we don't need to create a class implementation like this. We don't need a class implementation for interface. Instead, we can directly, what lambda function is saying is, you can directly call that method. You can directly call that method, and the method has two variables, right? We can directly call that method, and you can just simply implement it here right away. And you can say obj dot add of 10 comma 20. So you don't need that implementation class at all. You just need this interface, and directly from this interface you can call it from the main class. Okay, so let's run it. So this is functional interface. So this is the interface which we have created, and this is how we have to use it from the main. But what if we want to use an inbuilt interface? Say for example, if we have a class, right? If we have a class which is a runnable interface, for that one also we don't need a separate implementation for the runnable interface. Instead, we can just create the runnable reference like this, and then we can write our own implementation for the runnable interface, right? We can just say like anonymous method which doesn't have any name, and then you can directly do your implementation. Say like for example, you can do the implementation to iterate 1 to 0, or 0 to 10, or anything like that, right? Well, simply, okay. Instead of printing the numbers, I'm gonna say it as child thread, because it is coming from a child. This is a method implementation, which is yeah, it's a method implementation from the child. It's not coming from the main class. And let's run it. So this is like inbuilt. This interface is built in. um, yeah, so um, to run this thread, you need a thread object, right? Thread object to run it. Okay, and t dot run. When you say like this, like that, then only. So we have to give this object here, unless and until you will not. This thread cannot recognize which one to run, right? If it is not given that reference, it cannot recognize which one to run. So now it ran that child thread. So even in the main class also we can put this same iteration. So when you see it, there are two threads running, one from the child class method, one from the child method, anonymous child method, and another one is from the main. So if you see it, you will see the two. I mean, I have to change it, or I can say from main. Okay. Now you can see you see two different outputs, one from the main and one from the child threads. So yeah, so previously we have created our own interface and we um, try to write a lambda expression for our own interface, and this one is for inbuilt interface. Okay, this is how you can write a lambda expression for inbuilt. And let's do the same thing for collections now. Let's get rid of this data, all these things. It needs another bracket. Okay. All right. Let's do the same thing for collections. Okay. Let's declare array list which accepts integer data type. L equals to new array list integer. Let's add some values in it. 90. Okay, and let's just simply print it. Okay, so when we print this, we are just going to see the output, like how based on the how we have given the how we have added the inputs, right? But now if we want to print it in a sorting order, then we have an inbuilt class called collections.sort of L comma. The way we can do is using comparator. We have to for collections we have to either print it using comparator or comparable, right? So if we say comparator C, will it be okay? Yeah, so yeah, using comparator, we have to declare our own implementation for comparator, and then we have to give our implementation here. Then it will allow us to sort it for us, right? Because if you look at this, if you look at this, it's not showing up for me, the implementation of the sort method here. It takes a collection object and a comparator or a comparable comparable interface. Okay, let's quickly implement those that class. Let's declare a class in here, class my comparator. Okay, implements comparator, which takes integer, because we are declaring an integer data type, right? And then it I think I don't remember, I think it's compare or compare to, it's compare. Yeah, it's compare, right? Compare is the method that we have to implement it by so so we are taking two integers here. We are comparing two digits like this one and this one to numbers. And then if you remember, if this number has to come before this, if this object in collection compare, there is a concept say called if this number has to appear before this number, this object. Again, this is again two objects, right? If this object has to come before this object, it returns a negative value. If this object comes after this object, it returns a positive value, and if the both numbers are similar, it returns a 0. So let's implement that same logic. Why is it okay? Yeah, so this number is less than this number, it returns negative value. If it is greater, it returns a positive value. Positive value, else it returns 0, right? So now what we are going to do is we are going to pass our new comparator here. New my comparator, and this is how typically when we try to run our own implementation, we can do like that. So it is sorted, right? So if we want to implement the same thing in lambda expressions, the way we do is we have to say return L1 is less than L2. If L1 is less than L2, then you'll put a question mark, return L1. Else, for else you have to put a colon. So this is not a lambda expression, but this is you call this it is if I don't forget, I think this terminology, the expression is called as ternary operators. This is called ternary operators. So yeah, so we are checking for a condition here, and then question mark is like if and else, what is the result, this or that. So we are putting -1, which, so we are converting this whole expression into a ternary operator here. Okay, I'm just trying to show you that -1, and then if it is like if not, it goes to this expression, right? And then again question mark, then it's going to print +1, else it's gonna print 0. This is what it happens, right? So let's rerun this with the ternary operator. And yeah, here we go. We got this output sorted in a sorted order, right? Now instead of we implementing all these things, lambda expression will give us a support to declare it in the lambda expression, so that we can just get rid of this whole class here, right? Let's bring this down a bit, and then okay. So how we can go we can create create a lambda expression here. So we will create an object of this, a reference of this interface here, the same way how we have done so far till now. And then we are going to give equals to sign. And what is the input value we are going to give? This is the input value that we are going to give here. Okay. And and then we are going to pass this C over here. Okay. And now let's get rid of what it's complaining is, we have put this expression here, but we haven't give any. This is the return type that we are giving, but it is asking like what is the input type. So the input type for it is L1 and L2, right? And the lambda expression also it is missing. So when we give that, let's get rid of this class directly. We will fire it up, and here you go. We got the sorted order. So this is how we include lambda expressions for collection classes. They are like even there are the concepts for streams. Streams are also introduced in Java 8. So what it does is it just takes this list value, and then it iterates over the list one after the other. And then what we are going to do is we're going to just sys out. Okay. See, this is another lambda expression. So it will take values one after the other, and it just prints it out on the output. We can also insert some filters also in this streams. We can just even insert some filters. L dot stream dot filter. We can just say, you know, the value which is you're reading. We want it to make sure if it is even number. If it is even number, we are let's not put this one, it's getting confused. So the main intent over here is I'm filtering based on this output. I'm filtering all the even numbers only to be displayed into and I'm asking them I'm asking it to collect it into a collectors dot to list. Okay, and let's put this let's put the whole list inside a list integer here. Okay, we'll put it into a list integer L2 equals 2, and then let's import the list. It's complaining that list is not there anywhere in the package. We have just imported the list as well, and just print this L2. So when we run it, we are supposed to get only 90 because 90 is only the even number here in our list. Let's see. Yeah, see, we got just 90 here. Yeah, this is pretty much it. In our next session, let's look into how we can do lambda functions on Java objects. We have seen how we can implement it on a normal function. We have seen on interfaces, we have seen on inbuilt interfaces, we have seen on collections, but next time the video is becoming too long. I don't want to extend it anymore. We will see how we can implement it on objects like an employee object or student objects, how we can do it on objects with coding example. I hope you like it. You like this video. Please like, share and subscribe my channel. And do please give some comments. If you have any questions, please put it on. I'll come up with a new video on that, and we can go from there. I hope you enjoyed this video. Thank you and take care. Bye.